Hello guys, this is Nadeem from Maths TV. Hope you will like this video. Before starting, I just wanted to invite you to be a part of our YouTube family. You can do this by just clicking the red subscribe button. Also press the bell icon so that you get notifications for newly released videos. And do not forget to follow us on LinkedIn, Facebook and Instagram. Without wasting your time, let us start. Today we'll be going through Cambridge Mathematics, Pure Mathematics 1, 97091 May June 2018. Question number 1. The coefficient of x square is expansion of this one is 330. Find the value of the constant a. So what we will be doing, we will be treating them separately. These are two terms, so we need x square, so coefficient of x square in both terms. So for first term, we can write 2 plus x over 2 and whole raised to the power 6. This is basically our first term, and the second term is a plus x raised to the power 5. So in this one, we will be checking the x square term, which will be 6c2, because why we are taking this c2, because this will be x square in that one. So 6c2 and a raised to the power this minus this, which will be 6 minus 2, which is 4, and b raised to the power, which is 1 over 2x raised to the power 2. So if it is, if it is 6, we are writing here, this is 6 minus 2, and this 2 we are writing over here. Similarly, we can expand this also. This will be 5c2, and a raised to the power, a is first term, so a raised to power 5 minus 2, which is 3, into b, which is x raised to power 2. Now we can check with the calculator. 6c2, 6c2, this will be 15. So 15 into 2 raised to the power 4. So 2 raised to power will be 16, and this will be 1 by 2 square. So it will be 1 by 4 into x square. Now we can simplify this. 4 4s are 16 and 15 4s are 60. So 60x square will be for this term, and we can solve this side also. So 5c2, this will be giving us 10. So this side will be 10a cube and x squared. Now we can join them together because basically they are one term, so we can add them. So it will be 60, basically this will be 60 in a cube, 60a cube, not 60a cube, this is 10a cube basically. So we can write 10a cube plus 60, and x square we can take as common. Basically we have added these two, these are x square, so x square we have taken common, and 60 and 10a cube. So this will be a cube, this is equal to, is given 330, so we can write this as equal to 330. Basically this is coefficient of x square is 330, so we will remove x square. So coefficient of x square is this one, this is equal to 330, and now we can simplify and find the value of a cube. This will be 10a cube is equal to 330 minus 60, which is 270 basically. So 270, and a cube will be equal to 270 divided by 10, which is equal to 27, and this implies a is equal to 3. So this will be our answer. We have separately treated these two terms. We have solved first term, second term, and then we have added these two terms, and basically we added their coefficients, and after adding their coefficients we have replaced equal to 330, and then we solved for it. Question number 2. The equation of the curve is y is equal to x square minus 6x plus k, where k is the constant. Find the set of values of k for which the whole of the curve lies above the x-axis. So above the x-axis mean we will be checking b square minus 4ac, and it should be less than 0. And we can write it, we can shift this to other side, so b square should be less than 4ac, and for this equation we can write b square mean our a value is equal to 1, b value is equal to minus 6, and c value is equal to k. So these are the values of this equation we can replace here. So minus 6 squared is less than 4 into a, which is 1, into c, which is k. So this implies this side will be 4k and this side will be 36. So we'll divide by 4 and we will get 9. So k is greater than 9. So we can write k minus 9 is greater than 0. Now for the second part, find the value of k. Find the value of k for which the line this is tangent to the curve. So line this one is tangent to the curve. It means that this will be satisfying the curve also. So we can write x square minus 6x plus k is equal to 7 minus 2x. What we have done, we have changed this equation, which is y plus 2x is equal to 7. We have written y is equal to minus 2x plus 7, and we have utilized this equation and the curve equation which is provided over here, and we have equalized these two equations because they are saying that tangent to the curve line, this one basically they are saying find the value of k for which line is a tangent to the curve. So we can equalize them, and we now will have to simplify. We can shift this to this side. So x square minus 6x and plus 2x, this one, and plus k and minus 7 is equal to 0. Now we can add the like terms, x square minus 4x and plus we can write k minus 7 is equal to 0. This will be our c value, this is b value, this is a. So now we can write a is equal to 1, b is equal to minus 4, and c is equal to k minus 7. We'll be utilizing these values and we will check for b. We know in this case this will be b square minus 4ac will be equal to 0 and equal to, we can equalize them. So this will be b minus 4 square minus 4 into a value is 1 and c value is k minus 7 is equal to 0, and we can find the value of k. So this will be 16 and minus 4k and plus 28 is equal to 0. So 4k we can shift to the other side. So 4k is equal to 28 plus 16. So 28 plus 16 will be equal to 44. So k will be equal to 11, and this will be our k value which is required in this question. Question number 3. A company producing salt from seawater changed to a new process. The amount of salt obtained each week increased by 2% of the amount obtained in the preceding week. It is given that in the first week after the change, the company obtained this much salt. Find the amount of salt obtained in the 12th week after the change. So in the 12th week there will be 11 weeks which are completed. So we can apply this formula, compound interest formula, or we can apply this one as SN formula also. Basically this will be 100 raised to the power 11. Why we are taking 11? Because in the week of 12, when week of 12 will start, 11 week will be completed. Now we can simplify this. This will be 1000 into 1 plus 2 divided by 100 and raised to the power 11. This will give us 9946.99, which is approximately equal to 9950 kg. This will be our answer. Now the second part, find the total amount of the salt obtained in the first 12 weeks. So this is basically the SN formula, which is the sum of the values for 12 we will be calculating. So formula, if we want to write, first we can write the formula. Sn will be, for your understanding, Sn will be equal to A into 1 minus R raised to n divided by 1 minus R. So this formula will be utilizing, so as n value is 12 in this case, so A value will be 8000, so starting value will be 8000, and 1 minus R value is 1.02 and raised to the power 12, this one, and divided by 1 minus R, which is 1.02. And now we have to just simplify this. If we simplify, this will be 8000, and we can take fraction as well, and this will be 1 minus 1.02 and raised to the power 12, and bracket will be closed over, this will be 1 minus 1.02, and this will be resulting to 107,296.7178. So this is the calculator number, so we can round them as 107 and 000. This will be our final answer for this question. Now question number 4, the function f is such that f of x is equal to a plus b cos x, a plus b cos x. For this range, it is given for f of 1 by 3 pi is equal to 5 and f of pi is equal to 11. So we will utilize these two informations, find the value of constant a and b. So this one, f of x is provided, which is equal to, we know f of x is equal to a plus b cos x, and the range is x is greater than equal to 0, less than equal to 2 pi. And for this range, what we will do, we will check for f of pi by 3, sorry. So f of pi by 3 we can check, which is a plus b into cos pi by 3. So cos of pi by 3, we can check this cos of pi over 3, pi by 3. This will give us value, which is basically we'll have to check for the radian mode we have to change. If we first will change mode, shift mode, this will be radian 4, and now we can check this value. This is 1 by 2. Now you will have to use this in radian mode, and this will be 1 by 2, so we can write here 1 by 2, and this one they have provided is equal to 5, so we'll write equal to 5. So our final equation will become, this implies a plus b over 2 is equal to 5. This will be our equation for this. And for the second thing, which is f of pi, so f of pi will be equal to a plus b into cos of pi, and cos of pi, we know this is equal to, cos of pi is equal to -1, so we can write this equal to, basically we will be replacing this by -1. Cos of pi, this is equal to a plus b into -1, and we know this is provided as equal to 11, so we'll write equal to 11. So our equation will become a minus b is equal to 11. Now we have these two equations. One equation is this one and the second equation is this one. This is our first equation, this is our second equation. Simultaneously we can solve. To solve simultaneously, we can write this first equation over here, and now we can subtract by changing signs. This will be cancelled and this will be 1 minus 1 by 2 will be minus 3 by 2. B is equal to 6, and then we can shift this to this side. B will be equal to 6 into minus 2 by 3, and 3 2s are 6, so this is equal to minus 4. So B is equal to minus 4. This is what we got. Now we got B value, we need A value as well. So A value we can find in replacing. For example, we can replace in this equation A minus B is equal to 11. So A minus 4 is equal to 11. So A is equal to A minus 4 is equal to 11. This is basically minus 4 value. This is minus 4. So minus minus this will be plus. So it will be equal to 11 minus 4. So A will be equal to 7. So these are the two values which are required. A value is equal to 7 and B value is equal to 4, which is done. Now the second part, it's saying find the set of values of K for which the equation f of x is equal to K has no solutions. So we know f of x is equal to, we know it is a plus b cos x, and A value, we found A value as 7. So our equation will become 7, and this will be minus 4. So we can write here minus 4. So this will be minus 4 cos of x. So this one, for this range, cos x should be greater than equal to minus 1 and less than equal to 1. Now what we can do, we know this is equal to K value. K value will be for cos 1, basically if it is 1, it can be a situation that cos value is minus 1 and 1. So first we will take cos value as 1. So it will be 7 minus 4 into 1. So this will be resulting to 3. This will be one value, like for example, we can write here when cos x is equal to 1, and this will be the situation. And when cos x is equal to minus 1, cos x is equal to minus 1, then the same equation will be giving us, as this will be plus 4, so it will be 11. So these will be the two values, and for that one we can write K is greater than 3 and or K is greater than 11. So f of x is equal to, this shows what? This shows that f of x is equal to K. This one has no solutions. Hopefully you understood this part as well. Now this is vectors question. Question number 5. The diagram shows a three-dimensional shape. The base OAB is a horizontal triangle OAB. This is horizontal triangle in which angle AOB is 90 degree. AOB, this one is 90 degree. The side OBCD, this side is a rectangle, and the side OAD, OA and D, this one lies in the vertical plane. Unit vectors I and J are parallel to OA and OB respectively, and the unit vector K is vertical. So this vector is vertical, these are on X and Y plane. So the position vector of the position vectors of A, B and D position vector of A, B and D are given by OA is given, OB is given and OD is also given. Express each of the vectors dA and CA in terms of ij and k. So if we check dA, first our task we will take as dA. dA will be what? dA is basically this vector, which we can indicate by arrow, and we can take this root, which is this one, which is DO, or we can write minus OD. So we'll write minus OD vector and plus OA vector. So plus OA vector. So this will be our DA, and OD is provided, which is this one, and OA is provided. So both the values are given. We will have to just replace the values. So this will be minus of this one will be minus 2i and minus 4k, and plus OA will be plus 8i, and that's all. Now we'll have to add the like terms. So 8i minus 2i will be 6i and minus 4k. This will be our dA, which is required. Now CA, to go for CA is this vector, and what we can do, we don't have anything direct like a root like CD. We have this vector dA, but we don't have CD vector. So we can do, we can first find OC vector. OC vector, if we check, OC vector will be equal to OD plus DC. So this one, this vector plus this vector, this OD plus DC will be equal to OC vector, which we can show, and I will draw for you. We can show OC vector like this one. So this is our OC vector. So I will write OC vector is equal to OD plus DC vectors, and this is OD is provided, which is 2i plus 4k, and DC vector is basically the same as OB, and OB vector we can write plus OB vector, and this will be equal to 2i plus 4k, and OB is provided, which is 5j, so plus 5j. So our final this will be vector which we have to find for OC, which is this one. Now we will utilize OC vector, and we can write CA. CA is what? CA is OA and minus OC, or we can take this root, this one CO is basically minus OC and plus OA. So now our equation will become CA vector is equal to OA minus OC. So this will be our equation for this one. OA value we already have, which is 8i, and minus OC vector we just found this one. We will be changing sign of this, so we will write 2i minus 4k and minus 5j. So this will be, we can add the like terms. 8i minus 2i will be 6i, so 6i minus 5j and minus 4k. This will be the required vector which we have found for CA. Hopefully you got this. Now the second part, they are saying use a scalar product to find angle CAD. So angle CAD is required. CA and D. This angle is basically required. Angle CAD. So CA we already have, and DA also we found in part 1. This is our DA, this is our CA, and we know the formula for a scalar product, and that is CA dot DA. These two vectors will be equal to magnitude of CA and magnitude of DA into cos of angle CAD. So this formula we will be applying, and we will be finding it. This is need to be found, and this one we have, and magnitude we can find. So angle CAD will be equal to cos inverse of what? CA dot DA, this one vector, divided by CA magnitude and DA magnitude. So this will be what we will be finding, and now we can find the product for CA dot DA. This will be equal to 6 into 6 cross 6. This will be our basically CA dot DA we are finding. This will be minus 4 into minus 4. Basically I dot I and J dot J. Our CA is over here. This one CA dot DA. So this dot this. So this one I dot I we can find, J dot J and K dot K. Basically this is our DA and this is our CA. So I is there and K is there. So 6 into 6 and minus 4 into minus 4, which we have done over here. So because there is no J involved in this, so J will be 0, and we can find this one. So this will be equal to 36 plus this will be 16, which is equal to 52. So this will be 52. Now dA mod we can find, which will be 6 square plus 4 square root, and this will be equal to 52 root. And similarly we can find CA mod also, which is equal to root of 6 square plus 5 square plus 4 square, which is equal to 77 root. And now angle, we will be replacing these values in this equation. This equation will become angle CAD will be equal to cos inverse of this value CA dot DA, which is 52. So 52 over this will 52 basically this will be 52 over 52 under root into 77 under root. We can find this answer. Basically this will be 52 cos inverse of cos of 52 over root of 52 into root of 77, and this will be answer will be equal to this one, but we are using radian mode. We'll have to shift mode to degrees, and now we will calculate. This will be equal to 34.7. This is equal to 34.736, or we can write approximately equal to 34.7 degrees. This will be our answer. Hopefully you understood this. Question number 6. The diagram shows points A and B on a circle with center O and radius R. The tangents to the circle at A and B meet at T. The shaded region is bounded by the minor arc AB, this one, minor arc AB, and the lines AT and BT, angle AOB is 2 theta radians. A part, first part, in the case where area of the sector AOB will be this one, is the same as the area of the shaded region, show that tan theta is equal to 2 theta. For this question, what we will do, we will find area of the sector. So area of the sector AOB, we can write area of sector AOB will be equal to, we know formula for area of sector, 1 by 2 r square theta. So r square theta in this case is 2 theta, so we'll write r square into 2 theta. So this 2 will cancel with this one, so r square theta, this will be the area of the sector. Now after finding area of the sector, we can find area of the shaded region. So area of triangle, basically we will find area of triangle OAT. OAT will be, we can join this point with this for your better understanding, this one. So the lower triangle OAT, we can find the area of triangle OAT. This will be equal to a base into height, 1 by 2 into base into height. So 1 by 2 into base into height, we need to find the base, which is 80, and this will be perpendicular basically, and this will be adjacent. So opposite, this will be opposite over adjacent will be equal to tan theta. So we can take this as AT, we can write here AT is equal to r tan theta. So this value we will be utilizing in this one, which is area of triangle. This will be equal to 1 by 2 into base, which is this one, into height, which is r. So we can write r tan theta into r. So this is what we have done. We have separately calculated AT, and now we can write this as 1 by 2 r square tan theta. Now what we have done, we have found the area of sector separately, which is this one, and area of shaded region also. Basically we have found the area of triangle so far. We have to find the area of shaded region. So we will find, this is one triangle, so we will area of the shaded region will be what? Area of shaded region will be a double of this triangle. So I will write area of OATB, this one, OATB, this complete quadrilateral will be equal to 2 into 1 by 2 r square tan theta. And I'll have to move the page, sorry for that. No, this is done. This is what we have doubled this value, because this is half, so we have doubled this, so this will be cancelled, and this will be equal to r square tan theta. Now r square tan theta, now we can find the shaded region, area of shaded region. Area of shaded region will be equal to r square tan theta is the total area, and minus this area of the sector. So area of the sector will be this white portion, which we will be subtracting from this total. So r square theta. Now we can just take r square common, and we know this is equal to basically these two are equal. Area of shaded region is equal to the area of the sector, and area of the sector is this one. So we can write here r square theta. R square theta is equal to r square tan theta and minus r square theta. So we can write this one as r, basically the r square we can take common, so this will be tan theta minus theta, so this will be equal to r square theta. So r square we can cancel, so theta will be equal to tan theta minus theta, and this theta we can shift to the other side, and this will be tan theta will be equal to 2 theta. This is what we need to prove. Hopefully you understood this question. Now this is a B part, which is saying that in the case where r is equal to 8 centimeters and length of the minor arc is AB is equal to 19.2, find the area of the shaded region. So arc length AB arc length will be equal to 2r theta. So r value is given, which is 8, so 2 into 8, and this will be into theta, which is given is equal to 19.2. So we can equalize it and we can find theta value. So our equation will become 16 theta is equal to 19.2. So theta is equal to 19.2 divided by 16, and 19.2 divided by 16 will give us 1.2. So 1.2 will be over here. Now area of the shaded region, area of shaded region, we can write this one. We calculated this in the previous part, which is r square tan theta minus theta. You can refer to the previous part for this, and this is the equation which we derived. We will be replacing r by 8, so it will be 8 square, and tan of 1.2 minus 1.2, and this will be calculated as 8 squared into tan of 1.2 minus 1.2. This will be basically tan of 1.2. We need to put bracket over here. So this is giving us minus. I will double check this value. Basically we need to use radian mode for this one. So 8 square and tan of 1.2 and minus 1.2, this will give us 87.817. So approximately we can write 87.82. This will be our final answer. Hopefully you understand this. Now question number 7. The function f is defined by f of x is from x minus 2x square minus 12x. This expression is given for x belongs to r. Express this one in the form of this, basically completing square we have to do. So we can rearrange minus 2x square minus 12x plus 7. So we will be taking minus 2 first common, which is coefficient of x square. So remaining will be x square, and this will be plus 6x and plus 7 as it is, because we have taken common from these two terms only, and minus 2, and next we will be writing square of x plus 6 by 2 square, and minus this will be 6 by 2 square and plus 7. Now we will be writing this one as x plus 3 squared, and minus this minus 2, it will be resulting to plus. So 2 into this will be 3 squared will be 9, and plus 7. So this will be minus 2 into x plus 3 squared, and this will be 18 plus 7, this will be 25. And now we can compare this equation with this one. So our a will be, a is basically this constant. We can rearrange according to this one, and we can write 25 minus 2 into x plus 3 square. Now we can compare a is equal to 25 and b will be equal to 3. So this is done. Next part, state the coordinates of the stationary point on the curve. This, so we can take the derivative. So derivative of the given equation, dy over dx, will be equal to minus 4x minus 12, and because this is stationary point, so we'll replace equal to 0. So x value will be 4x is equal to minus 12, which will give us x is equal to minus 3, and this value we can replace in the equation, which is y is equal to 7 minus 2x square minus 12. Replacing x is equal to minus 3, we will get minus 7 minus 2 into minus 3 squared minus 12, and 12 is also having x, so it will be minus 3 like this. So this will be 7 and 9 minus 18 and plus 36, and this will be equal to 25. So x value is minus 3 and y value is 25. So our point will be minus 3 and 25. Hopefully you understood this. Then the third part, the function g is defined by g of x. Basically they have defined this. X is greater than k. State the smallest value of k which g has an inverse. So that value will be minus 3. So k value we can write k is less than minus 3. Fourth part, this is simple. So fourth part is for this value of k, find g inverse of x. So y, we know y is equal to 25 minus 2 into x plus 3 square. We have replaced a and b values, and this is basically the equation which we got. Now we can make x as subject. To make x subject, we'll shift this to the side. So y minus 25 will be equal to minus 2 into x plus 3 squared. Now minus we can shift to this side, basically changing sign. So it will be 25 minus y is equal to 2 into x plus 3 squared. And now what we can do, we can shift this 2 also to the side. So it will be 25 minus y divided by 2 is equal to x plus 3 squared, and we can take a root on both sides to cancel this square. So x plus 3 this side, and this side will become 25 minus y over 2 the root. Now we will be shifting this 3 also, so our x value will become as 25 minus y over 2, and this is under root, and minus 3. Now we can swap this x and y, so y will be equal to 25 minus x over 2, this will be under root, and minus 3, and this is what we know, this is g inverse of x, which we need to find. This is done. Hopefully you understood this. Now this is question number 8. Points A and B have coordinates h, and 4h and 6. 4h plus 6 and 5h. This one, basically these are points A and points B respectively. The equation of the perpendicular bisector of AB is, this is the equation of perpendicular bisector. Find the values of the constants h and k. So for this one, if we just quickly, for your understanding, we can draw a rough drawing. For example, this is our point A, and we know A has coordinates h and h, so we'll write h, and h for A, and for B we can write coordinates as this one. So 4h plus 6 and 5h. Okay, so this is done. Now perpendicular bisector, say this is the midpoint. So perpendicular bisector will be this one. So say this is point M. So this is point M, and equation of perpendicular bisector of AB. This is the equation. So this is 3x plus 2y is equal to k. This is the equation for this line. Now find the coordinates of midpoint. Midpoint will be M, we can find from these 2 points. So h plus 4h. H plus 4h divided by this is h. So h plus 4h divided by 2, and h plus not 4h, it is 4h plus 6 basically. So 4h plus 6, and this will be h plus 5h divided by 2. So these will be the coordinates of the midpoint. We can simplify the coordinates of M. It will be 5h plus 6 over 2, and this will be 6h by 2, which means 3h. So this will be the coordinates of this. Now this equation we can write in y is equal to mx plus c format, and that will be, we can write 2y is equal to minus 3x plus k, and 2 also we can shift, so y is equal to minus 3 by 2x plus k. Now this is indicating that m is equal to minus 3 by 2 for this line. So gradient, basically this is the gradient of this line, and gradient of AB, m of AB will be equal to reciprocal of this one and change sign, so it will be 2 by 3. So we have the gradient. Now for this line we have the gradient and we have coordinates of m. So we have one point in the gradient, so we can write equation of line in point slope format, and we can write that equation. So m of AB we found, so we can write basically this one. Instead of writing that one, we can directly so find this h value. So 12h is equal to basically, so what we will do, basically we will utilize these 2 points. Gradient of these 2 points we know equal to this. So we'll write the gradient equation for these 2 points. So we'll write m of AB will be equal to, we'll apply the gradient formula, which is y2 minus y1 over x2 minus x1, which is equal to y2 is 5h, so we'll write 5h minus y1, which is h, over x2, which is 4h plus 6, and x2 minus x1, which is h, and we know this is equal to 2 by 3, so we have written this equal to 2 by 3. So our equation will become 4h over, this will be 3h plus 6, 3h plus 6, this is equal to 2 by 3, and now we can cross multiply, so this will be 12h is equal to 6h plus 12, and this will shift to this side, so 6h is equal to 12, so h is equal to 2. Now h is equal to 2, we can replace and find the value of m, and m is what? M is basically 5h plus 6. So 5h, which is 2 plus 6 by 2, and 3 into h, which is 2. So final point m will be 10 plus 6 will be 16, divided by 2 will be 8, and this will be 6. So we can write this. This will be our m point. Now we have to find the value of k, and k we can find by replacing h value. From this equation we can find basically we know 3x plus 2y is equal to k, and x and y value we can replace 6 and 8. This is 8 and 6 basically we will replace here. So this will be 3 into 8 and plus 2 into 6, this will be equal to k, and this will be 24 plus 12 is equal to k, which is equal to 36. So k is equal to 36. This will be our value of k. Hopefully you understood this. We are done with this question number 8. Now here comes question number 9, which is a curve is such that dy by dx is provided and 2 and 5 is the point on the curve. So find the equation of the curve. Basically integration we have to do. So integral of this equation 4x plus 1 under root, so we can write 1 by 2 raised by 1 by 2 dx. So this equation we have to integrate. So integral of this one will be what? This will be the power we will increase by 1, so this will be 3 by 2 divided by 3 by 2, and derivative of this one is 4, so we'll multiply by 4 and plus c. Now at point, given points 2 and 5, so this will be what? We will replace x value, so 4 into 2 plus 1 whole raised power 3 by 2 divided by, this will be cancelled 2, and so it will be 6, so this will be 6, and plus c value, and this one we know equal to y, and y value is 5, so we can write here 5. So now we can find the value of c, and this will be, if we simply, this will be 8 plus 1 9, we can write 3 square whole raised per 3 by 2 over 6 plus c is equal to 5. This will be cancelled, so 3 square will be 27, so 27 divided by 6 plus c is equal to 5, so 3 2s are 6, 3 9s are 27, so 9 by 2 will be 4.5, so 4.5 plus c is equal to 5, so c is equal to 5 minus 4.5, which is equal to 0.5 or 1 by 2, 0.5 or 1 by 2, so c is equal to 1 by 2. This will be our value which will replace, and our equation of the curve will become y is equal to 1 over 6 into 4 plus 1 4 plus 1, basically it should be 4x plus 1 raised to power 3 by 2 plus 1 by 2. This is basically the c value. So this will be our final equation. And the second part of this question is a point P moves along the curve in such a way that the coordinates in y coordinate is increasing and at the constant rate of this one. So rate of change is given units per second. Find the rate of change of the x coordinate when P passes through this point 2 and 5. So rate of change of y is given, dy over dt will be equal to 0.06. This is provided, and dy by dt, we know this one, dy by dt is equal to what? Is equal to 4x plus 1, and we can find dy by dx. Basically dy by dx will be at x is equal to 2, will be what? Will be replacing this. This will be this is basically dy by dx. So this will be dy by dx. So at 2 will be 4 into 2 plus 1, and this will be root, so this will be 9 under root will be 3. So we got this. Now dy over dx is equal to dy over dt into dt over dx, and this value dy by dx we know is equal to 3, so we can replace here 3, and this is equal to dy by dt is also provided 0.06, and this will be dt over dx. And now we can shift this to this side and this one to this side, so dx by dt will be equal to 0.06 divided by 3, and we can divide this. 0.06 divided by 3 will be given as 0.02. So dx by dt will be equal to 0.02. This will be our final answer. Now show that second order derivative multiplied by first order derivative is constant. So we'll find d2y over dx square, d2y over dx square. We can find this, and this will be we'll take a derivative of the derivative. Like for example, this one we can take derivative of this. So it will be 1 by 2 into 4x plus 1 raised by minus 1 by 2 into derivative of this one will be 4. So this will, we can write this as 2 2's are 4. So this will be 2 over under root of 4x plus 1. Now this is second order derivative, and first order derivative we already have this one. So this multiplied by this, we will multiply these two. So what will be our equation? We can write d2y over dx square into dy over dx is equal to this 2 over root of 4x plus 1 multiplied by this dy by dx, which is under root of 4x plus 1. So this will be cancelled with this, and we will get 2, which is equal to constant. So we can write this as constant. Hopefully you understand this. Now question number 10. Solve the equation 2 cos x plus 3 sin x is equal to 0 for the given range. So what we will do, we can divide everything by cos x. So cos x plus 3 sin x is equal to 0. So divide everything by cos x. So cos x, and this will be also divided by cos x. This side will remain 0. This will be cancelled. So this will be 2 plus 3 sin x over cos x is tan x. So tan x is equal to 0. Now we can find the value of x. So 3 tan x is equal to minus 2. So tan x is equal to minus 2 over 3. So x is equal to tan inverse of minus 2 over 3, and we can find that one inverse tan of minus 2 over 3, and this will give us value. Basically we are using the radian mode. Sorry, we have to change the mode. So it should be the degree mode, which is this one. So if we calculate this, this will be minus 33.69, and x value will be, basically we need within this range, within this, and this is out of range. So we will write x will be equal to 180 minus 33, basically 0.69. We are basically adding this in 180. So what we will get, we have this one. So plus 180 plus 180 will be equal to 146.3. So it will be 146.3 degrees, and this x can be equal to 146.3 degrees, and we can add plus 180 more for this one, and this will be 326 because it's repeating after 180. So these two values can be the answers. Hopefully you understood this. Now the last question, no, not the last question, it's the second part of the question number 10. It is saying sketch on the same diagram. So on the same diagram we have to sketch these two curves, and for this range we will be just drawing a rough sketch of this one. So we can draw for example x-axis and y-axis like this one, and after drawing this we can just take as this one as 1 and 2 and 3. So this one also we can take it as 1 and 2 and 3 up to this one. So roughly we have drawn this one as, this will be 1, 2, 3, and this will be -1, -2, and -3, and this will be 0. And similarly we can draw on x-axis also, so 1, 2 and 3. Basically we can take a bigger range, so that bigger axis scale we can take bigger, so that we can get a clear diagram. So this one, 3, 6, 9 and 12. Okay, now this is done. It's not compulsory to take, I'm just taking the equal intervals for your understanding. So this will be 90 degrees, this will be 180 degrees, then we can have 270 degrees, and this will be 2 pi or 360 degrees. So we have taken this one, this required scale we have taken on x-axis, and these are the values. And what we can do, we can check for this, basically we can check for this 0. So cos 0 will be 1 for this equation. First we are drawing this equation, so cos 0 will be 1. Now cos 0 is 1, so y value will be 2. So we can take the first point when angle will be 0, so our point will be this one. So one point for this curve will be this one. So this cos 90 will be 0, so we'll get the second point over here, and the third point 180 will be -1. -1 multiplied by 2 will be -2, so we will take -2 in front of this one. So roughly it will be like, for example, over here. And then for 270 again it will be 0, so it should pass through this one. And for 360 it will be 1, so 1 multiplied by 2 will be 2. So we will get this point roughly over here, and we can put cross over here. So our curve will be like this one. So if I want to draw the smooth curve, so I will turn the page, and smoother sketch we can draw like this one. It should pass through this, and after passing through this one it should turn like this one, and basically this will be the curve, and it should be smoother like this one, so we can have a turn like this. So this is basically the cos x, which is intersecting this on these points which we have shown, this one, this point, and this one. Now we have to show the other y is equal to -3 sine x. So if we replace 0, sine 0 is 0, so it will be this point, and sine pi by 2 is 1, so it will be -3. So for this one it will be over here, and for 180 it will be 0. So for 180 it will be 0, so we can take this point, and for 360 it will be basically 1 for 270. So it will be -1 for 270, so we'll take +3 value, so our curve will be going up, and it will be up to -3 value, so +3 value, sorry. So it will be up to this one, and then passing through 360 will be this one. So if we start the curve from here, so it will be curving like this. It should pass through 180, and it should pass through this one, and it should curve like this one, and from here it should be passing through 360 as well. So we can adjust the curve. Basically it will be passing through 360 as well. Now this is basically the curves which we have drawn for this part. We are done. Use your answers to part 1 and part 2 to find the set of values of x for this range for which this is greater than 0. So we know we are provided with 2 cos x plus 3 sine x is greater than 0. So we'll shift this to this side. So 2 cos x is greater than minus 3 sine of x. Now we will be checking the parts of basically this curve is, we will indicate this curve is and this one is y is equal to minus 3 sine x, this one, and this curve is y is equal to 2 cos x, 2 cos x. So this is equation for this curve. Now we will be taking the for example parts of y is equal to parts. We will be checking parts of y is equal to 2 cos x, which is this equation. We need the parts which are above this curve. So we'll write above equation y is equal to minus 3 sine x. So for this one, these are the above portions. Basically this is above portion which I'm indicating over here, and this is also above portion which I'm indicating over here. So this portion and this portion, these two portions are above this curve. So we can give this one in the form of range, like for example x should be greater than equal to 0 and less than equal to what, 146.3 degrees, and this value we found in previous part, which is over here. So x is 146.3, and we can write this one. So this will be our equation will become x is greater than 326. Basically this will be x is greater than 326 degrees and less than 360 degrees. Basically what we have done, if you want more explanation, we are finding x value from this one 0 to this point, which is 0.3, and from where we got this value, we got value from this are part 1 and this is part 1. These two values we are using and writing the range for these two portions. For this portion we got this 326. This is basically 326 value, this value, and for this one we got this value, which is 146.3. These two exact values we got in part 1. Hopefully you understood this question as well. So this is also done. Now the last question of this paper, which is question number 11. The diagram is provided. The diagram shows part of the curve, and the curve is this one, and the line, which is this, intersects the curve at the point P and Q. Show that the tangents to the curve P and Q meet at the point at a point on the line y is equal to x. So the given equation, this one, we know they are saying the diagram shows part of the curve, this one and this one. So on these points at P and Q, first of all our target is to find the coordinates of P and Q. So to find the coordinates of P and Q, will equalize these two equations. So our equation will become x over 2 plus 6 over x is equal to 4. And now we can simplify this. We will multiply by 2x, so we'll get basically x square and plus 12 and is equal to 8x. Basically this will be 8x, and we can shift this to this side, so it will be x square minus 8x plus 12 is equal to 0. And this quadratic equation we can solve mod 5 3, and coefficient of x square is 1 and coefficient of x is minus 8 and constant is 12, so values are 6 and 2. So our values will be 6 and 2, these two values, and these two values we can replace in this equation. And what we can do, we can find this as like for example, we have equation y is equal to 2 over 2, y is equal to this. In this equation we are replacing these values, so I'll move the page so that you can see this. So at x is equal to 2, our equation, these are the two values which we found. Now we are replacing this 2 value in this equation to 2 over 2 plus 6 over 2, and this will be equal to 1 plus 3, so it will be 4. So our P point will become 2 and 4. So 2 and 4 will be our P point. So at x is equal to 6, so now we can check x is equal to 6, and y value will become 2 over 6 over 2 plus 6 over 6, so this will be 3 plus 1, again we'll get 4. So our point will become 6 and 4, so this will be our Q. So we found P and Q. We can write the coordinates of P and Q. P is having coordinates 2 and 4, and Q is having coordinates 6 and 4. So we found the coordinates after finding that one. Now we can find the basically the this one tangent. They are saying that the diagram part of this intersects the point P and Q. Show that the tangents to the curve at P and Q. So we'll find tangent at P, tangent at Q. So in this one, dy over dx, first we will find the tangent, derivative of this. So it will be 1 by 2 minus 6 over x square. This will be our derivative. So at x is equal to 2, so dy over dx at x is equal to 2 will be equal to what? Will be equal to 1 by 2 minus 6 over x 2 square will be 4, and this will be equal to, we can solve this, this will be 1 over 2 and minus 6 divided by 2, 6 divided by 4, this will be equal to minus 1. So this will be minus 1, and the second dy over dx at x is equal to 6 will be equal to, we'll move the page, so this one, this is equal, at x is equal to 6 will be equal to 1 by 2 minus 6 over 6 squared, which is equal to so 1 over 6, 1 by 2 minus 1 by 6 will be equal to 1 by 3. So these two values we got, and now what we can do, we can write tangent at P. So we can write tangent at point P will be equal to y minus y1. We will use this gradient, and the point we will be using this one. So we will write y minus y1, which is 4. So y minus 4 is equal to m, which is minus 1, into x minus x1, which is 2. So we'll write this one. And similarly tangent at Q. So tangent at Q will be equal to, similarly we can write this as gradient. So y minus y1, which is 4, is equal to 1 by 3 into x minus x1, which is 6. This one we are using this q value, so this will be 6. Now they are saying that they are tangents of the curve meet at the point. So meet at the point, it means they are equal. So these two are equal to each other. So minus 1 into x minus 2 is equal to 1 by 3 into x minus 6, and this we can solve this one and find the value of x. So from this one we can get the equation 4x is equal to 12, so x is equal to 3. So this will be x is equal to 3. Now we can find this one, basically the y value. This x value will be replacing in y minus 4 into is equal to minus 1 into 3 minus 2. This is the x value which we have replaced, and we will get y minus 4 is equal to minus 3 plus 2. So minus 3 plus 2, which is equal to minus 1. So y will be equal to minus 1 and plus 4, so y will be equal to 3. This will be our value. So tangent meet at, basically we are getting x value and y value same, so this implies tangents meet on the line y is equal to x. So this is also done. The second part of this question, find showing all necessary working the volume obtained when the shaded region is rotated. The shaded region is rotated through 360 degree about x-axis. Give your answer in terms of pi. So for this one we will be taking integral from this point to this point, which is x value is varying from 2 to 6. So integral 2 to 6, and this will be pi for rotation 360 degrees. So this will be x by 2 and plus 6 over x whole square and dx, and integral of this one pi value we can write first, and 2 to 6, this will be, we can first open the square before taking integral. So a square will be x square by 4 plus b square will be 36 over x square, so 36 over x square plus 2 into ab. X will cancel with this and this will cancel, so ab will be 3, so 2 into 3 will be 6, so we will get 6 over here and dx. Now we can integrate. So pi we can take first, and integral will be, so I'll write the integral like this one, and next step will be over here, x square over 4 plus 36x over x square and plus 6. This one dx will integrate this, so this will be pi, and this will be x cube over 12. Integral of this one will be x cube over 4 into 3, which is 12, plus this will it will be minus because this will go up, and integral of x minus 2 will be minus 36 over x, and this will be plus 6x, and limit will be from 2 to 6, and this will be, now we can replace the upper limit, and if we replace the upper value of the limit, this will be sorry, not limit, integral. So this will be 6, and this will be 6 cube over 12 minus 36 over 6 plus 6 into 6. This will be the value which is by replacing upper into this one, and this will be 2. If we replace, this will be 2 cube over 12 minus 36 over 2 plus this will be 6 into 2, and this will be closed. And now we can just type this to find basically 6 cube over, what we can do, we can take fraction 12, so raised to the power 3, and minus This will be 36 divided by 6. I'm just typing for convenience, so this will be plus, this will be 36, and bracket will be closed, and minus the second value will be 2 raised to the, okay, so 2 fraction will be 12, and raised to the power 2, it should be 3 basically, so it should be 3, and then minus value minus 36 over 2 will be 18, so directly I write 18, and plus 6 into 2 will be 12, and this will give us 160 over 3 pi. So this pi and 160 over 3, so 160 over 3 pi, this will be for this one. Now we will be subtracting the area which is for this one. This portion will be basically, this will be pi r square h, for which will be, height will be this one, and r will be 4, so r square will be 6 minus 2 will be height, which is 4, so our value will be pi r square h we can find, which is pi, and r square will be 4 square, and h will be 6 minus 2, so this will be equal to this will be 4, and this will be 16, so 64 pi, and this is basically the total area, this one, and we will be subtracting the area which we calculated over here, so 64 pi minus 160 over, it's 160 over 3 pi, and this one we can calculate 64 pi minus 160 over 3 into, this will be pi, is equal to 32 by 3 pi, so this is equal to 32 by 3 pi. So we are done with this last question as well. Hopefully you understood each and everything, and if you want notification for this type of videos, just subscribe Maths TV, and don't forget to press bell icon also, and introduce this channel to your respected teachers, and also forward this link to your friends and class fellows so that they can also get benefit of it, and we will get reach to the more and more students. Thank you very much. Take care. Bye.